Here's part 2 of the BMW M4 Vargas turbos that I'm doing a rebuild on. This is an internal inspection. Looking inside of these turbos, this is what I'm looking for. I can see there's some scarring on the inside. There's also some scarring on the outside. Oh, I dropped that one. Let's go to the next one. Scarring on the inside. Scarring on the outside. And if I take my fingernail across them, it's a rough surface, which isn't normal. So I kind of felt like there's an oil contamination problem here. The other things I'm looking for too, they did use a proper upgraded one, so I like that. Use a proper thrust bearing. You can see a little bit of wear here. Oil hole size, that looks pretty good. This shaft actually I think looked better than the other one. The other one had some grooving there. This one has a little bit, but not much. This front feels good. The shaft groove looks good. I'm checking the sidewalls to make sure this groove is not worn on the top or bottom side. We're going to use a feeler gauge. You can get these at Advanced Auto Parts. This one I have selected is 3/1000. I've already checked this. What I like to see is 2.5 right here. I got 3. I'm pretty happy with that. 3 is the width of a hair. So this is a pretty tight 3. This one has some scarring here. It's not as bad here as it is here. I know it's a little hard to see that. Right here is where it feels worse. Our turbines will replace that. So I'm just going to go ahead and replace both. That way we don't have to worry about this issue, and then I'll balance it out. We've got damage on the fins. So normally I would replace this if I can get a replacement turbine for this, but if I can't replace this, I'm just going to sand those fins down and then clean them up best I can and rebalance it. I had and sanded all these blades down because they had some nicks in them, not too many, but also I like it better to be a smooth surface rather than that point finish mill in the end. And where it had rubbed a little bit, I filed each blade down too on both sides. This compressor wheel is painted black. You can see right there where they marked it and they did the balancing. That would be for an assembly balancing setup. And then I think they also cartridge balanced it too, like VSR. If you need a replacement compressor wheel for these, the part number is D420. It's a KTS wheel. So this is a 19T billet wheel. And this looks right to me from what I could tell. I didn't take any measurements or anything. But I know the 20T wheel doesn't go in there because I already tried to put that in there. So it looks like it's just a 19T. It's a TDO4HL 19T. It looks like the radius matches up and everything, so I think it's right. And here, what I checked for to make sure that this is cut, which it's not. I don't know if that was a major issue or not, but that should get cut, so I'm going to cut that. I put the journal bearing shaft and the spacer in there so you can see how much space you have for that spacer to rotate. You don't want that spacer hitting up on the bearing housing there, so I cut that back a little bit. The factory bearing housings always need to be cut there. They're even tighter than this. This is an aftermarket bearing housing. It's just made a little bit tighter than I would prefer, and I don't want this guy to have any issues. And if it develops any shaft play and starts moving around, it's going to start hitting that and can cause an even more dramatic failure. Actually, I think that might be some rod flake right there. Or some kind of contamination in there. Maybe his engine blew up. I'm trying to grab it. I don't know. There's probably a piece right there. I'm looking at the journal bearing seats. It looks like it's pretty clean in there. Not a lot of scarring or anything. Sometimes it can be a little harder to tell. The backside general bearing seat looks good. Little scratches, but nothing too serious, I think. You got a dog face. Hey, dog face. And the rear seal area looks good. Here's how you check the rear seal gap. You put the rear seal inside the bearing housing. And then I'm going to take the feeler gauge. This is my 7/1000ths. I'm going to put it in the gap. So it's a pretty tight 7. I prefer 2.5 thousandths on that. The closer the better. Really, you just want it to go in there and have as little gap as possible, but it's best to have at least 2 thousandths gap, because otherwise these can swell and then the seal won't go back down in there. A lot of the Mitsubishi bearing housings are around 5 to 6 thousandths anyway, so this is pretty reasonable. And by the time we use a staggered rear seal, it'll help make that gap non-existent in that area anyway. So this is just making sure that it's not going to leak oil, because we know our piston ring is going to be sitting up against the walls in the proper tolerance, and it's going to have the proper gap, so the oil should not leak out of here. Also, another thing to do that's really important is placement of the gap. When this seal goes in, it stays in that position, so I always try to put the gap facing the top oil feed area of the bearing housing, because the oil drips from here down. So if the oil builds up in the cartridge, and reaches this area, it will leak out much easier. But with it being at the top, it's less likely for it to leak out at that gap area because the oil's moving down. The reason I'm replacing these turbines is simply because of the grooving on this shaft. I just don't want to have to worry about that. It's really important for this to be in tolerance, because it makes sure that the journal bearings are spinning at half the speed of the turbine shaft. If this tolerance wears out and the journal bearing is no longer spinning at half the speed of the shaft, then the journal bearings do not get enough lubrication on the inside of them, and it causes this to wear out even more rapidly, and then eventually have a really serious failure too. So if I'm going to replace the shafts anyway, I'm just going to go ahead and do them now, and he's not going to have to worry about it later on. I'm moving on to the turbine housings. This needs to be welded up right there, or at least I always do that, because that can fall off there. It looks like it's already starting to come out a little bit or something. You can see that. Other things I'm looking for, you can see those cracks there. I'm gonna try to deburr all that. Not all that's gonna come out, but I'll help prevent it from cracking worse by rounding those edges. Those start because this was never deburred properly. This turbine housing is stainless steel, so I know that costs a ton of money to develop this. So I think that's good that he actually made them stainless. It's cracking right there. This isn't really that concerning to me. I mean, you don't want it to crack, but a lot of factory manufacturer stuff does crack, even being stainless steel. The only ones that I've seen are super rare to crack that are stainless steel from factory are the N54 turbine housings. I'm going to move on to the next turbine housing. Just one small crack there, or maybe a couple other minor ones, nothing too serious. So I'll have to deburr that. And here we have another crack and a couple more. I'm just going to try to deburr this and do the best I can to preserve it. Even though it is cracked, I still think that this is a very usable part. Both of these are very usable parts, and they're not in terrible condition. It's really common that factory turbine housings do crack anyway. My overall viewpoint on these turbos is that they're pretty good quality. Besides, there's just a couple things that I would change about them. That front seal plate should have never had an issue like that. That should be easy to correct. but they probably already got the parts, and it was going to cost a bunch of money to fix that, or they were in a pinch, so that's why they did that. It should be cut bigger for that collar, but it doesn't look like that would be a real serious issue, but I think that should have been done anyway. And as far as the shaft wearing out that way, that was mostly a debris issue getting in the turbo and causing it to wear out. It should have never happened like that if these turbos were clean to begin with. Either these turbos, when they were received, were dirty on the inside, or they somehow contracted contamination from the engine oil or from the transfer to the engine. When they were putting them in there, maybe they didn't have it blocked off and some dust or debris got in there somehow. If the engine blew up like a spun rod bearing and caused it to get into the turbo, causing it to wear out, or possibly an engine rebuild where they sandblasted some things and there was sand still in the motor that then got in the turbo. That would be pretty common, but it is an M4 and it's not like it's a super old car, probably like a 2016 or something. These shouldn't be having the engines rebuilt, but it is possible that that could have happened. And in one case, I actually seen somebody sandblast the valve cover to make the engine bay look nice. And I kept warranting his turbos all the time. And then somebody eventually called me and told me that, yeah, he sandblasted his valve cover. I guess eventually he got rid of that car because I warrantied it like 3 times. And then he just never contacted me again. Or maybe just replaced the engine or something. Or I guess the engine could have just completely blew up and he couldn't no longer, it didn't make sense to repair the turbo because he didn't have a good motor anymore. As long as these turbos were clean before they were installed and the engine oil was clean before it was installed and there was no issue with debris, then these turbos should have worked perfectly fine. Either here, it's something that I can't really determine. I just know that there was something inside of it that was causing the bearings to wear out.